So first of all, talking about integration by substitution, this is also known as U sub. Okay. And in U sub, we're going to actually use this. Yes.
For long response, for true response questions.
U sub is
universal.
Yeah. It is. Okay. We're going to use U sub for 3 types of problems. Okay, and the first and most common one is composition functions. And that would be f of g of x or something like that. Okay, composition of functions. The second one would be for a product. Okay, so you might have the integral of, let's say, f of x times g of x dx. And then the last one would be a quotient. So we'd have the integral of f of x over g of x dx. Okay. So this is going to help us out just a little bit, especially for those types of problems that if we can't multiply it out, or it would just take us so long, and the odds of us making a mistake are so much greater. So first of all, this is called U sub because you literally make a substitution with the letter U. And this right here is known as a dummy substitution, not because the variable is dumb, but because you're using something other than x or y, so they generically chose the letter U. Okay, now when you use this U sub, you can't have any other variables. Everything would have to be in terms of U. And then when you turn around and substitute back in the whatever you made the substitution for, typically it's in terms of x or t or whatever the variable is, there should be no u's. So you really need to keep track of your work. So for those of you that still cannot work linearly on your paper, you need to make sure that everything is clear when you make your substitution, what your substitution is, what the derivative and the integral are. Okay, you have to be very, very careful, and everything needs to be clear. You cannot make any assumptions here. Okay, so if you still haven't worked that out, you need to work it out. All right, so the first thing in step number 1 that you look for is some composition, or it's not just a composition. You might look for a product, a quotient. And when we're talking about a composition, it could be, for example, I'm just making this up, but like the cosine squared of x. So when we rewrite it, it's the cosine of x quantity squared. So that's the cosine inside a square function. Does that make sense? So you have one inside the other. Okay, and you would determine what you're making the substitution for, and you're going to identify that. This right here will be your inner function, meaning what's on the inside, and then you would actually have to take the derivative of it. Okay, so what you have is du dx, meaning the derivative of your u term in terms of x, and this would be g prime of x. You basically are going to move this over. That's where they get this from here. Just like we did when we were solving for the equation to get it into the y equals form, it was dy dx is equal to, and we would take the integral, and the dx would move to the other side. So what's going to happen is once we make that substitution, then it would produce an integral that is expressed entirely in the form of u. Okay, now one thing you need to consider is that sometimes you cannot take the derivative, or excuse me, the integral by hand. There are some integrals where you're going to have to use the calculator. Obviously, if we're giving you something on a quiz or a test and we are literally testing you on your integral knowledge, we're going to give you something that you can take the integral of. So you're not going to have something that's not possible. So that's not really an option right now. Does everybody understand what I'm saying? Okay, so it's definitely important. So again, you're going to produce an integral that's expressed entirely in terms of u, okay, and the differential will be in terms of du. All right, so in the second step, once you make that substitution, then it would be easier to integrate. It's not going to be some product or quotient that looks super confusing. But again, as I said before, this might not be possible, but for the most part, 99% of the time, 99.99999% of the time, you're going to be able to do it. And then in the last step, once you have integrated, you're going to replace u with g of x and express your final answer in terms of x or t or whatever the original variable was. Okay, so in the first few problems, what we do is we actually give you what your U sub is. So I want to go through some of the things that you're going to look for when you are actually doing this. So this would be the original problem, okay, and this is what you would be given, and you actually have to determine, okay, what am I going to make my substitution for? So a lot of the questions that I typically get are, how do you decide that? What you typically are looking for is something that you would be able to integrate. So that would be something to a power or something to a higher power, because sometimes you have two terms that are both to some degree. Something underneath a radical, or maybe in a denominator. So these are all things that we're looking for. So for example, they tell us what they want U to be. So they're saying that this is going to be our U sub. So even though it's written here, I want you guys to get in the habit of saying, okay, U is going to be equal to 1 plus the sine of t. So what that does is it allows us to begin to rewrite our integral in terms of U, meaning I have the integral of U to the 9th power. Now what do you notice? If I make this substitution right here for U, is there anything still there? Yeah, you have cosine of t dt. And if you remember what I said in the first step, you cannot have, once you make that U sub, anything else in terms of any other variable. Everything has to be in terms of U. So what's going to happen is, once you make your U sub, you're going to go over here and take the derivative of this. Because remember, when we're integrating, we would have the integral of 2x dx. Because we're taking the derivative and going back to the original. That's what the integral is. Okay? So that means when I take the derivative of U, this is du. What's the derivative of 1? 0. What's the derivative of sine? Yes, it's the cosine of t dt. So look here. This is what is left over here. So if I make the substitution and say that du is equal to the cosine of t dt, do my t's go away? They do. So now I'm making the substitution for this with this. So now my integral is all in terms of U. Okay. If I asked you to integrate this, does that look confusing? Now, if I ask you to integrate this, less stuff, right? So we go through the procedure, meaning you add 1. So now my new exponent is what? U to the 10th power. And what do I do for a coefficient? Divide or multiply by the reciprocal, right? So this is 1 over 10. And what do I have to make sure I throw on there? Plus c. Okay. This was a lot easier to integrate. Now, I need to go back to what I made my substitution for. What is U? 1 plus the sine of t. So I'm going to take this out and put this in. 1/10 times 1 plus the sine of t to the 10th power plus c. Okay, now watch. I'm going to take the derivative using the chain rule. So what is this constant? 5, 7, 12, 11. What's the derivative of a constant? 0. So now this is gone. When you take the derivative, so I'll do this in a different color. When I take the derivative, this 10 comes down in front, times 1/10. 1 plus the sine of t to what power? The 9th power, times, because I have to use a chain rule, what's the derivative of 1? What's the derivative of the sine of t? dt, right? These are gone. This is what I've got. Look back up at the top. Are they the same? Does everyone see how that works? It's a lot, right? So there's a lot of steps that you got to take into consideration. Okay? Questions on A? Do you see why I want to review this on Friday? Yeah? Okay. All right, let's take a look at B. So, remember I gave you some hints. We're looking for something that has a power, or maybe under a radical, or in the denominator. So, do you see why this says that we want U to be 2x squared plus 5? Why? A couple things. It's in the denominator, and what else? It's under a radical. Okay, that's not a problem. So that means if I make the substitution for 2x squared plus 5. Okay? What do I need to get rid of? What is in the way so that I can have all u's? 3x dx. Okay, so let's make our substitution. They did it for us. So we're going to use this because it's off to the right. So what did I do in the previous problem with this? We took the derivative. So we've got du is equal to 4x dx. Okay, so take a look. This is different. Here's my x dx. Here's my x dx. What's the problem, though? Okay, the coefficients are different. What do we typically do with coefficients, though? What have we done with them when we're using the chain rule or when we were integrating? Couldn't we put them on the outside and deal with them later? Okay, so a coefficient is a coefficient. They're movable. The variables, not so much. Meaning, if I can move this 3 somewhere and move this 4 somewhere, then I'm safe. Everybody understand what I'm saying? Can this 3 go to the outside? It's coefficient. How could I move this 4? I can't put it on the outside. There's no outside.
Can you divide the...
You can. You can move it to the other side. So I want to isolate this. So I have 1/4 du is equal to x dx. And when I rewrite this, that means I have the integral with the 3 on the outside. So that means my x dx is in the top. What is x dx in terms of u? More specifically, 1/4 du. So I'm going to put the 1/4 out here. Coefficients, they can go to the outside. I can deal with those later. The du is in the top because that is my x dx. And now I have the square root of u. Okay, now some of these parts of the steps you're going to be able to move along and kind of do them all at once, but I want you to see where things are going. So we know we do not have a quotient rule, correct? I could rewrite this as a rational exponent, which is what? 1/2 power, but I need to get it to the top. So more specifically, how am I going to rewrite it? Exactly. So this is 3/4 times the integral of u to the negative 1/2 du. Okay, can we integrate this right here? A lot faster than all this stuff, right? Okay, so 3/4 is a coefficient, so it stays, times. I'm adding 1, which means I'm adding 2 over 2. So what's my new exponent? So what comes down in front then? A 2. So I'm going to put a times 2 and then u to the 1/2 plus c. Okay, so that means I now need to put this back in. So this is 3/2 times, I can write this however you want. What is u? 2x squared plus 5. Do you want a radical or a rational exponent?
Rational exponent.
Okay. 2x squared plus 5 to the 1/2 power plus c. Okay, questions? How would I check my answer? Take the derivative. Okay, this takes a lot of practice. Okay, because at some point we're not going to tell you what u is anymore. Yes, sir?
Could you keep the 2 coefficients on the inside of the
Integral?
Yes.
Well, part of the reason that I moved it to the outside was because I really wanted these 2 green pieces to be the same. So once you got it all and you could see it, if it was on the inside, it's not going to make a difference. It's still a coefficient. Doesn't matter. Okay, any other questions before we move to the last 2 problems on this page? All right, so here, we took the derivative of e to the x, and it was what? E to the x. We took the integral of e to the x, and it was plus c. But yeah, e to the x. So what's the problem here? Other than the fact that they're telling you what the u sub is, what's the problem? Yeah, I have a coefficient with that variable, right? It's not just e to the y. So if we were to take the derivative of something like this, remember it would be e to the negative 3y times the derivative of whatever's in there. So we have to make our substitution. So right here, if I made this substitution for u, I would say, okay, what's the integral of e to the u du? It's just e to the u, correct? Okay, but I need to do some work with that. So here, when I make the substitution, we have the integral of e to the u. The problem is I need to get rid of this dy. So you take the derivative. Okay? Du is equal to what? Negative 3 dy. What's the problem? What's holding me back from my substituting right now? Yes.
Negative 3.
Yes. So what did we do with this before? How do we take it out? Divide or multiply by the reciprocal. It's the same thing, right? So we have negative 1/3 du is equal to dy. Okay, so what am I going to do with that negative 1/3? Yeah, stick it in the front. And what am I missing here? Du. Yep, because this dy becomes the du. It's right here. Okay, what's the integral of e to the u? E to the u. Negative 1/3 e to the u plus c. So now this is negative 1/3 e to the what power? Yep, plus c. Okay, do you see WHY? My u sub is what it is. 2 reasons. What are they? In the denominator and, yeah, the power. Okay, because we can always take that u to the 5th power up to the top, right? Okay. So I'm going to rewrite this integral. In the bottom, I have u to the 5th because we made this equal to u. What do I need to get rid of? The dx. Okay, so we're going to take the derivative of this. Du is equal to what? What's the derivative? 1/3. What's missing? Dx. Okay. So what's the problem? 1/3. But we can move that, right? It's not really a problem. So what do? Multiply by 3. 3 du is equal to dx. Okay. Do you remember on the very first page, last class, we had the integral of dx over something is equal to? What did I do with that dx to make it not multiplied? Like right now it's sitting here. Remember we moved it here. So then what did I put in the numerator? A 1. So can I put a 1 here, my du here, and what goes out here? 3. Okay. What do I need to do now before I can integrate? Yeah, bring it to the top. So you have 3 times the integral of u to the negative 5th du. Okay, be careful when you are integrating negative exponents. So remember, integration, you are adding 1. So that means my new exponent is now what? That's right. So you've got 3 u to the negative 4th, but what do I need for my coefficient? Negative 1/4. So this is times negative 1/4, and then I have plus c. I have a little bit of simplifying to do, but that's fine. Typically, you're going to write your exponents as positive. So what is this telling me to do before I make my substitution? Yeah, take it to the bottom. So you have negative 3 on top, and then 4 times 1/3 x minus 8 to the 4th power plus c. Okay, questions up to this point? It's a lot of steps, a lot of things to remember. Yes?
What happens to the du?
When you integrate, it just becomes u.